Hey, this is Mr. Charnetsky, and this is Algebra 1, Unit 3, Lesson 2. And we're going to take a look at looking at key features of some tables and graphs here. So, in this first situation, we have Alonzo, Maria, and Sierra are floating in inner tubes down a river. And Alonzo is taking some measurements of the depth of the river as they are floating down. So for the 2-hour trip, he's measuring at different intervals what the river depth is. And Maria is measuring the distance that they are from their starting point as they float along the river. So Alonso made a table and Maria made a graph. So our first step here is we're going to take a look at Alonso's data and what are some of the key features that we can read just from the table. So if I'm looking at this, one of the first key features that I will notice is at the start. Okay, when we start at 0 minutes, that is our initial depth. Okay, that would be what we would call our y-intercept if we were looking at it on a graph. So this is the y-intercept, or our starting point, if we were graphing it. Okay. Some other key features that I might notice is that as I'm looking at, as time goes along, as time moves forward, we look at our depth and we see, oh, it's going up, and then it goes down. So this graph goes up and down, and then up again and down again. So what I want to do is I want to, first I'm going to label this y-intercept. This is at 0 time. We have a depth of 4 feet. We also have intervals of increasing depth and decreasing depth. So increasing depth, well, starting at 0 time and all the way up to at 30 minutes, this is increasing. And then we have decreasing depth from that 30 minute all the way down to 60 minutes when we're back down to 4. And then we're increasing again. All the way up to 12 at 90 minutes. And then we decrease the rest of the way. Okay. So one thing I notice here is that it's never constant. It's always either increasing or decreasing in this particular case. So we have intervals of increasing depth and decreasing depth. So one of our increasing intervals is between a time of 0 to 30 minutes. That is our first interval of increasing. Our second interval of increasing happens between 60 and 90 minutes. And this is how we write one of the ways that we would write those intervals. So we'd use brackets indicating that from 0 to 30 we're increasing, and also from 60 minutes to 90 minutes we're also increasing. We are decreasing between 30 minutes and 60 minutes. That's our first decreasing interval. And also between 90 minutes and 120 minutes. Okay. There are two other key things I want to take from this table. First is our domain. So our domain would be all of our x values in the graph. Okay, where do we start in the x values and where do we end up? Well, you're looking at what are our x values? What would be the horizontal axis if I was actually going to graph this table here? So, well, my x-axis would be the time, and my y-axis would be the depth in feet. And the domain is, well, where do we start and where do we finish on our x-axis? Okay. So our domain in this case is starting at 0 and going to 120 minutes. That's our domain. Our range would be the possible y values. So our graph starts at 4 and we go up to 10 and then we're back down to 4 at some point. Then we go up to 12 and then we're back down to 5. So our graph is looking something like this. So the lowest value for our range, is 4. And the highest value for our range is at that maximum value, which is at 12. So our range is between 4 and 12 on our graph. Okay, so there's a lot we can read from the table, even without having a graph here. Let's take a look at the graph. So this is the same situation. We're still in the inner tube floating on the river, but this time we're measuring our distance that we've traveled in feet versus time. So some of the key features that I could read here. So first of all, an intercept, or y-intercept, that's 0, 0, because that's where we started. At time we are starting at 0 distance. We could look at what are increasing and decreasing intervals, and it seems to me we are increasing the entire time. Right? We're always getting further away from where we started, which makes sense. So the entire plot is increasing. So the increasing interval is going to be from 0 to 120 minutes. And there is no decreasing interval. So we're just going to say not applicable. There is no decreasing. The domain is all of our x values, and it's actually going to be pretty much the same as our increasing interval, because the entire domain, the entire time, we are increasing. So it's going to be the same, that 0 to 120 minutes. The range. What are our possible y values for this graph? Well, our lowest value on the y-axis is 0, and our highest value, it's going to be hard to, we have to try and figure this out from the graph here. We're over 10,000, let's see what they're going by. So 2,000, 4,000, 8,000, 10,000, so they're going by 2,000s each unit here. So this is 12,000, 14,000, 16,000, somewhere above 16,000, maybe 16,500 if I'm guessing. Let's see if we read back there. Nope, there's no words that tell us how far it actually travels. We're just going to have to kind of guess. That's okay. So approximately between 0 and 16,500 is what I would guess is the range. Alright. There doesn't seem to be any other key features that we could read from this graph. Oh, one more key feature that we could read is a maximum value. Our maximum value is the highest point right there. That's our maximum. And that maximum is at the coordinate of 120 minutes. And we have a distance of 16,500. Okay. So let's take a look at some observations and see whether we agree with these or not. So first of all, the depth of the water increases and decreases throughout the 120 minutes of floating down the river. So if we look back up here, yes, it does. That's exactly what we graphed up. There's increasing and decreasing sections. So we are going to agree with that. B, the distance traveled is always increasing. Again, that's exactly what we saw here. So the entire domain is increasing the distance. We're always getting farther away from our start. So that is another agree. The distance traveled is a function of time. Yes, time is our x value, and so distance is in terms of time. So yes, I agree with that. The distance traveled is the greatest during the last 10 minutes of the trip, during any other 10-minute interval of time. So the last 10 minutes, are we the furthest away than at any other point? And absolutely. We're definitely the furthest away the last 10 minutes of our trip. The domain of the distance time graph is all real numbers. Well, even though we could put any number in between here and the line is connected, we at some point we don't have anything before any negative numbers, and it seems to me that we have stopped at 120 minutes. So our graph has a little bit of a restricted domain. It's not all real numbers, but it is all the numbers. It is all the numbers between 0 and 120. The y-intercept of the depth of water function over time is 0, 0. Well, that one is false. We have the y-intercept. The y-intercept is 0, 4. When we started, our depth was 4 feet. In fact, 0, 0 wouldn't make sense for a depth because, well, you wouldn't float if you had zero depth. Distance traveled increases and decreases over time. That is another disagree. If we look here, it is only increasing. We're only getting further away as time increases. H. The depth of the water is never 11 feet. Well, if we look at our depth, at some point we have a depth of 7, and we go from 7 to 12, so at some point in between 7 and 12, we're going to cross 11 feet. So, and then same thing when we go from 12 down to 9, at some point we're going to cross 11-foot depth at some point. So even though it's not on our table, we don't see 11 feet, at some point our depth does have to be 11 feet. So the depth will be 11 feet, somewhere between, if we look at our table here, somewhere between 80 and 90 minutes and 90 and 100 minutes. They will have to cross that depth. Okay. The range of the distance time graph is 0 to 15,000. I think we said our range was somewhere above 16,000. So definitely goes above. So if these are going by twos, 12,000, 14,000, 16,000. So it's higher than 15,000 on the higher end. So I'm going to disagree and say the range is 0, and we said 16,500. The domain of the depth of water respect to time is 0 to 120. I think that's what we said for our domain. That is what we said, 0 to 120 minutes. So we're going to agree. The range of the depth of water over time is 4 to 5. Well, our depth of water, we said the range was from 4 to 12. We had a maximum of 12. So definitely not going to agree with that one. So the range is actually from 4 to 12. The distance time graph has no maximum value. I disagree. We found that maximum value. That maximum value is 120 and 16,500 feet. Max. That was our maximum. The depth of the water reached a maximum at 30 minutes. Well, let's take a look. At 30 minutes. So 30 minutes we have a depth of 10. That is not our maximum depth. At 90 minutes we're at a depth of 12. So our maximum value for this graph, as far as we could tell, is at 90 minutes with a depth of 12. And actually, to be perfectly honest, we don't necessarily know this is the maximum because he's taking measurements every so often. Maybe this graph actually goes up a little bit higher between 90 and 100 minutes. We don't know. Okay, we just know that for sure the maximum is not at 30 minutes. So there is a higher depth at 90 minutes. Okay. We are going to skip this graph here and go straight away to our takeaways. So, a little bit about notation. We have been using interval notation to mark like increasing intervals. So, for example, or domain and range. So if I took a look at increasing between x of 5 and 25. Okay. Interval notation, we could write it as using our brackets 5 and 25. That's interval notation. You might also see written as an inequality where x is less than or equal to 25 but greater or equal to 5. That's another way that we can write notation. Okay. So another example would be our range. So range between -2 and 100. So I would write that as an interval or as an inequality, and since we're dealing with range, y would be using y numbers. So between 100 and -2. So two different ways that we can write notation for that. Okay. So for our retrieval, and you're going to be doing this on your Ready, Set, Goes, if we're asked to graph two equations and then find the points where they intersect, well, first of all, we have some graph paper here, but let's actually put some axes on this. Oops. Sorry. Let's do put axes right in the middle. There we go. That's our x and our y. Okay, so f of x. I'm going to graph this in blue here. So there's our y-intercept. So that's the first place I'm going to go. I'm going to go up to 4 on the y-axis, plot a point. And then here is our slope. It is negative, so this is a slope of -5 over 1. So that means we go down 5, 1, 2, 3, 4, 5 over 1. Down 5, 1, 2, 3, 4, 5 over 1. And now I've got enough points I can actually graph this. I'm going to use a straight edge to get a nice clean graph here. Okay. So there's the graph of the first function, that is f of x. For g of x, I'm going to use a green line here. This has a y-intercept of -3. So I go down to -3, plot that point. The slope of that line is a positive 2/1, so this one goes up 2/1, up 2/1, up 2/1, up 2/1, up 2/1. And there is the graph of g of x. Okay, and we can see where they intersect. Right there, that is the point of intersection at 1, -1. Okay, where the two lines intersect. So in your Ready, Set, Go, you are going to be looking at some key features, and you're going to be finding some points of intersection, and you're going to be, again, practicing writing explicit and recursive equations. So questions 2 and 3 here. For number 2, we can see that we are decreasing by 3 each time. And my y-intercept here would be at 61, so my explicit is going to be f of x, this is f of n, equals -3n plus 61. Or I could write it as a recursive as f of n equals f of n minus 1 minus 3, and then I also need my first term here, so f of 1 equals 64. For number 3, we are dividing by 2, or you could say that the same as multiplying by 1/2 each time. So times 1/2 times 1/2 times 1/2. So my explicit equation, g of n equals, so I need to go backwards a little bit, find my starting point. So 0, if I multiply this by 2, that gives me 128. So that's my starting, 128 times 1/2, that's what we're multiplying by each time, to the power of n. That's my explicit. The recursive would be g of n equals g of n minus 1 times 1/2. And I would need my first term, so g of 1 equals 64. Okay, so that's it for lesson 2. At this point, you should work on your Ready, Set, Go and practice working through some of these problems.